Right. Dipotso tse feng tse re nang le tsona ke eng e motho a hlokang clarity ka yona mo maybe e leng hore I understand based on
how parallel the resistance here decrease.
Parallel the resistance, the total resistance of the circuit here decrease. Why it decrease? It's because as you connect your loads in a parallel combination, automatically what happens is the total resistance of that circuit decreases. And this becomes very much clear when we deal with a practical demonstration. If really a practical demonstration where we connect the load in a parallel combination, we draw another circuit where we connect the load in a series combination using the very same amount of battery 9 volts. The bulb will glow more brighter than this side. Why? It's because opposition in opposition in therefore how opposition in bulb how eba dim. How opposition in because connected in parallel, the brighter more than this side. So we can use the same bulbs are connected in series, the same bulbs are connected in parallel. Second say two different. Would say the glow are more brighter than those ones. Simply because combination how come it's in parallel. Come on, it's in series. Come on, the total resistance increase. It's a high increase, it's a current flow on gamu, even. Therefore, if current flow on gamani ilinyane balpu ya dim. Kamuna total resistance along opposition to the flow of current. Ya decrease agamu. And as you decrease the resistance, you are allowing more current. You are allowing more current to flow inside of this. Therefore, balpu how it glow up brighter. That is the actual difference. Ya parallelly in the series. That is why the total resistance ya decrease agamu. Come on, Tomang, hand to oppose. If you could say come on, Tomang, more strength. So feet. That's why bulb puts out it glow more brighter because anything aiming as a resistance, ya how in. Therefore, current you gonna flow elingat. Come on, resistance ya ingat because bona with a Otamilo overcome load to anticipate. And how can I come on the mat? Okadaulan some two, who loses some of the energy. Camilla how to come ugenagamu, Uluan so by the time Otoluan said the resistance yagamu, already loses the mark. So that is why a bright tongue, a dim, because now we increase the load. And usually it is very same to overcome the load. So because of that, bulb how ya deep. Marekamani or provided two different ways how we travel. And because by doing that would decrease the resistance of the circuit. And then if we decrease the resistance of the circuit, we allow more current to flow. And as you allow more current to flow, it's bright. Because usually, Baba habanze balwanisa kamu, Baba mbafitile balwanisa kamani. So bata share strength, ulwanisa two different enemies, kaba tuba two different. Because richerilo, wena lwana lo, nakeka lwana lo. But more we want ulwanisa batu baba beliwa. That difference. So that is why there is more autodima because the energy we have. And as you fight these individuals, you are using more energy. Margamani, we split it. Two enemies split it differently so that high. Therefore, the value more strength because rather than Mutoy right. And then I will share some of the problems that you can encounter as a grade 9 learner. The problem so solve. Because the word problems. And then after word problems, we will deal with the problems that are circuit related and see how we can navigate around that. Right. So suppose only a word problem. if the battery has 9 volts and the current flowing, in fact, the total current and the total current flowing in the circuit is maybe 2 amperes. Calculate the resistance, the total resistance. Calculate the total resistance of the external circuit. Now, suppose this is the question that you are provided. If the battery has 9 volts, which is the total amount of energy that the battery can supply, and then in flow current 2 amperes, as you take the multimeter and you measure the amount of current that is flowing, flow current 2 amperes. Now the question is, in fact, 0.5 amperes. Calculate the total resistance of the external circuit. Now, be very careful at the wording. If the battery has 9 volts, this is the total voltage. The total current, because we are using Ohm's law. Ohm's law, everything VIR. It deals with total voltage. It deals with total current, it deals with total resistance. But these things will become more clearer in grade 12 when we deal with grade 12 electrical circuit. To understand our V totally and so on. How is it usable? We understand I think in grade 11 or grade 12. But here I do have tutorials in electrical circuit as a grade 12 where I give a more clearer descriptive way of analyzing these electrical circuit. But when I will deal with that when you get there. So Ohm's law, the total voltage, the total current, and the total resistance. Hence, if the battery has 9 volts, a grade 12 learner will know that 9 volts, get the EMF, get the total voltage, the total energy that the battery can supply. Again, and the total current flowing is 0.5. Calculate the total resistance because Ohm's law is total. Total voltage, total current, and total resistance. Right. So let us try to draw the circuit and analyze exactly what is happening more. How do you just a second? Okay. Suppose on a bulb key. Right, and then on a switch it closed. Right, on a battery. On a battery how 9 volts. How to current a flow more 0.5 amperes. Again, current being the rate at which the electron flow, how fast the electrons are flowing, passing through a point. Again, now on a voltage, on a current, over the resistance, opposing the flow of the electrons, the flow of current. Value electron if area filter this opposition area resistance value. That's what we are asking. Right now, the formula total resistance. Total resistance is a way total resistance is total voltage divided by total current. Right now, on a total voltage A, we say battery 9 volts. Now, on a total current A, we say 0.5 amperes. Mplelena ke bokae 9 divided by 0.5.
18.
Bokae?
18.
18. 18. Remember, resistance is measured in ohms. So get the amount of opposition, the value of this substance opposing the flow of current. Ke bokae value ya ntwe 18 ohm. So come on, how lo reka this light bulb? Ho flow a current ya 0.5 and then the supply source ya in 9 volts. Also ntse ba automatically raw. Come on, resistance ya this light bulb ke 18 ohm. So bona na value ya teng you dimo jwang. Ha value ya teng ile udimo, ga tseba ba tlamelo fulo we current e nyane. That's what we have said. We have said now current ile voltage divided by resistance. So ha current ile nyane ka mantswe mang resistance e udimo. And ra bona hore current e nyane ke 0.5 ka mantswe mang resistance e tlamele be jwang e be udimo. Ke ya. This is very important to understand this basic thing more. Very, very important that you understand. That is why I try by all means to explain it in detail so that you understand it through a practical demonstration. This is very, very important. So come on, le high the bulb tse glowang haholo tsena. That is why this one fast. It's because the allow current e feed because resistance is at the low. So how resistance ya bulb is low, it will allow current to fit and that is why it's in this one fast because the allow current e feed and how the allow current e feed the chisa fast. How chisa fast you will allow current e feed mo that is why the tap how ka we tshwara ifuthumetsi yo bolella go tap wena e ala wa mollo mo ngata wetseng o fete and ha e etsa jwalo ina le resistivity e low e tlo hloka speed. These are some of the things that you guys need to wrap your mind around. So it is very important that always when we teach we try to make a practical demonstration so that you are at the end of the day understanding the concept. Aksebela ba sharp mo. I cover chance on. Don't have chance on. Right. How do another problem? Now that the critical problem is about resistance. Rebonur alright. How resistance is low dim. Currently, jonga pa jong efats. And rate ba rebelwa ke inki ohm's law. Current is inversely proportional to resistance, provided that the voltage, the energy of the system remains constant. Yeah? Right. Now, how do the second problem? Now, harsana voltage. When we feel current resistance, that voltage. Now, suppose a circuit comprises of a 6 ohm resistor worth 3 amps flowing in the circuit. Calculate the energy of the system. Calculate the energy of the system. Kani bracket mo supply voltage. But what? Now, this is the second question. Suppose the circuit comprises of a 6 ohm resistor with 3 amperes of current flowing. 3 amps flowing in the circuit. Calculate the energy of the system, which is the supply voltage. Now, let us try to draw that so that we understand exactly what is happening. Now, I'm going to try the very same thing. Switch the circuit is closed. Positive and negative. How about voltage? The energy is supply. But the resistance is 6. And even the current flow is 3 amps. So, resistance, current. the energy that was supplied so that will flow with 3 amperes on a resistance of 6 ohm na ke bokae. Right, ke a tseba hore voltage, total voltage e lekana le total current multiplied by the total resistance. This is exactly what I know, again. And then from here, now I get total current. Yeah, give little 3 amps. Okay, multiply a total resistance, that is 6 ohm. Now give guy 3 times 6. 18 again, 18 volts. So come on, German. The battery arrow, keep battery 18 volts. Kiona eka alawang or flow current 3 amperes if the resistance is about the load to 6 amperes. So this is something more. Current here how? Give 3. Resistance here how? Give 6. Bona resistance is 1. Resistance is 1 UD. Current is 1 fast. Always and always there is this inverse proportional relationship. So this is the most important thing that you need to understand. And many of the things that revolves around this that I discuss when we deal with previous exam related problems. Right. For vandaag. Let me just give you a chance to copy all this so that I'm meeting if we have some time.